Welcome to Learnpedia, the ultimate JEE and NEET prep tool currently being used by more than 20,000 aspirants. Now, take a look at this actual JEE question and see if you can answer it. If you think you got the answer, post it in the comment section below. To understand the concept behind this question, go ahead and watch this video further.
For definition, we will take it for capillarity. A glass tube of a very fine bore throughout the length of the tube is called a capillary tube. If the capillary tube is dipped in water, so this is a capillary tube. If this capillary tube is dipped in water, water wets the side of the tube and rises in the tube. If the same capillary tube is dipped in mercury, then the mercury is depressed. Why? Because the surface at the point of contact is concave like this, here at every point of contact. So inside this also it will be contact. Resultant surface tension force will be in the upward direction. So this upward direction surface tension force pull the water in the upward direction. Therefore, there will be a rise in the water when a capillary tube is dipped in water. Whereas in the case of mercury there is a depression at the point of contact. Angle of contact is more than 90. So here also there will be a depression and the surface will be convex. So resultant surface tension force will be in the downward direction. So the liquid will be pulled in the downward direction. So there is a fall of liquid in a capillary tube when the capillary tube is dipped in mercury. Whereas when the capillary tube is dipped in water, there is a rise of liquid or rise of water in the capillary tube. This rise will be till the position where the weight of this water, the excess whichever water is there in the capillary tube, balances the net upward force. This phenomena of rise or fall of liquid in a capillary tube, we call it as capillarity. A glass tube of very fine bore throughout the length of the tube is called capillary tube. If this capillary tube is dipped in water as shown in this figure, the water wets the glass. Angle of contact is less than 90 degrees. The surface of liquid in the capillary tube is concave. Therefore, a resultant force acts on the water in upward direction and water rises in the capillary tube. Similarly, if the capillary tube is dipped in mercury, theta is greater than 90 degrees. The surface of liquid in capillary tube is convex. Therefore, a resultant force acts on the mercury in the downward direction and the mercury falls in the capillary tube. This rise or fall of liquid in a capillary tube is called capillarity. So, it is a phenomena of rise of liquid or fall of liquid when a capillary tube is dipped in the liquid. Rise or fall of liquid in a capillary tube is called capillarity. Capillary rise. Height of a liquid in capillary tube, Ascent formula. Consider a liquid which wets the wall of the tube, such as water. It forms a concave meniscus as shown in the figure. Consider a capillary tube of radius r. Radius r is the radius of the capillary tube. Let us call this as r. Dipped in liquid of surface tension T and density rho. Let H be the height through which the liquid rises in the tube. Let P be the pressure on the concave side of the meniscus. PA be the pressure on the convex side of the meniscus. The excess pressure P minus PA will be equal to 2T by R as we studied earlier. So here I have taken angle of contact is less than 90 degrees. Therefore, the liquid rises in the tube. If the angle of contact is more than 90 degrees, there will be a fall in the capillary tube. The liquid will fall in the capillary tube. So here we have taken a liquid which wets the glass. Capital R is the radius of the meniscus. This is the meniscus which you have taken. Imaginary circle we can draw. This is the imaginary center. This will be the radius of the meniscus. Due to excess pressure of the liquid will rise in the capillary tube till it is balanced by hydrostatic pressure of the excess liquid in the capillary tube. That is the liquid which is present here. Say it is up to height H rho g will be the hydrostatic pressure. For equilibrium, net upward force, that is 2T by R, should be equal to H rho g. calculating the value of Kepler or the radius of the concave curved surface, we can calculate by knowing the value of H, we can calculate the surface tension. Consider the liquid which wets the walls of the tube, forms a concave meniscus. This theta is less than 90 degrees. Let the pressure on the concave side is P and pressure on the convex side is PA. The force due to excess pressure balances. The force due to excess pressure provides the upward force, resultant upward force. So P minus PA is equal to 2T by R, where T is the surface tension, R is the radius of the curvature of the concave surface, R the radius of the meniscus. Now the liquid rises in the capillary tube till the net upward force balances are equal to hydrostatic pressure. The liquid rises in the capillary tube till it becomes equal to hydrostatic pressure. Hydrostatic pressure is what? H rho G. Thus, in equilibrium, 2T by R is equal to H rho G. Here theta is the angle of contact, small r is the radius of the tube. So, if I take triangle O, this point is A, let us call this point as B. In triangle OAB, this is small r, this is capital, this angle will be theta, 90 minus theta, this angle will be theta. This is OAB. AB by OA is equal to cos theta. AB is, the cos theta will be equal to AB by AO, that is small r by capital R. So we can write capital R as small r by cos theta. So capital R is the radius of curvature, whereas small r is the radius of capillary tube. So I'll replace this capital R by small r cos theta. 2T by R cos theta, R by cos theta is equal to H rho G. The height to which the liquid will rise we can calculate as 2T cos theta by R rho G. This is called ascent formula. This expression we call it as called ascent formula. So understood what we have done here? The liquid will be pushed up because of the surface tension. The meniscus is concave. Therefore, the excess pressure will be there outside. The difference in the pressure will push the liquid upward. So difference in pressure P minus PA is equal to 2T by R. So liquid will slowly start moving upward. It will go on moving upward till this is balanced by the hydrostatic pressure of the excess liquid in the capillary tube as compared to the liquid in the trough. Hydrostatic pressure is H rho G. So when 2T by R is equal to H rho G, the liquid rise will stop. R is the radius of the meniscus. Since we don't know the radius of meniscus, we can write capital R in terms of radius of capillary tube as capital R is R by cos theta. This value of capital R we substitute here. We can calculate H is 2T cos theta by R rho G. This is called ascent formula. This much height the liquid will rise in a capillary tube. By knowing surface tension and angle of contact, theta is here the angle of contact, R is the radius of capillary tube, rho is the density and acceleration due to gravity, we can calculate to what height the liquid will rise in the capillary tube.
Hey there, hope you understood the concept. Here's the solution to the question asked at the beginning. Found this video useful? Hit the like and share icons to enjoy more such videos. LearnPedia's JEE and NEET prep tools contain more than 4,000 questions and over 20,000 solved examples. These can be accessed online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also try a free demo of our product before buying.